Hello everyone, we are Group 5. I am Janatul Firdaus Mitu. To start with, our project implements the given encryption table using a microcontroller. We have used LED lights to represent the corresponding output statuses. For this project, we are using Proteus Sketch, which is a complete solution for testing and virtually prototyping embedded system designs based on microchip technologies microcontrollers. This software enables us to capture schematic and stimulates the circuit we have designed. We have also used Logisim to build our circuit. Logisim is a logic simulator that allows circuits to be designed and simulated through the use of a graphical user interface. Lastly, using Arduino IDE, we have done the Arduino code. It connects to the Arduino hardware to upload programs and communicate with them. That's it from my side. The rest of the discussion will be done by my other group members.
Assalamu alaikum. So this is the logism circuit which we will be using to build our main circuit, and this logism is derived from the given truth table, and as you can see in the truth table it is in 4 bit, so we will be getting 16 outputs. So using this truth table provided to us, we created k maps, and from the k maps we derived 4 equations or expressions for output 0, output 1, output 2 and output 3. And using these said equations we build a logism, and in the logism we can see that we use 4 inputs via switches, 4 LED outputs, and this LED outputs for the first one O0 is connected to 3 AND gates. The first AND gate is connected to the input 0, input 2 and input 3, and for the second AND gate we can see it's connected to input 1, input 2 and input 3, and the third one is it input 0, input 2, input 1 and input 2, but the input 2 is connected via a OR gate as per our equation, derived equation from the k-map. And just like using following the k-map derived equations, we build the other 3 outputs, and when we go to analyze our circuit and our table, we can see it matches with the one provided to us, which proves that our table is working correctly. And for the implementation of the said logism by a microcontroller, the next part will be handled by my group mate Tosiful Bari. Thank you.
Assalamu alaikum. In this project, I am doing the software part. For this drawing part, at first, I have loaded all the necessary component to build this circuit. We are using Arduino Uno for our project. In the digital part of the Arduino, I have used pin number 2, 3, 4, 5 as the switch input and pin number 10, 11, 12, 13 as the output for LEDs. I have also used 10K registers as a load. To build this simulation, I need a hex file. It is basically a hexadecimal file which contains the uh, setting or instructions given in Arduino IDE. We will see how to generate hex file and load it here. Uh, as for the coding part, at first I have initialized all the pins that I needed. In the setup functions, I have declared which pins are input and which are output. The main instructions are inside the loop function. Using digital read function, I have stored the current logic state of the pin. These 4 lines are the K-maps done by my teammates Fahim Hossein for 4 different outputs. Pin value is sent to the LED using digital write function. Now let's compile this code. After the compilation, we will get the hex file location here. Let's copy it and paste it here. Let's simulate this circuit. Our simulation is started. Now let's see if it is giving the right output. To check this output, uh, let's see, in the initial state 0 0 0 0, we will get 1 0 1 0 1 0 1 0. Let's try another one. For input 0 0 1 1 0 0 1 1, we will get 1 0 0 0 1 0 0 0. As for 0 0 0 1 1 0, 0 1 1 0, we will get the output 0 1 1 0 0 1 1 0. Let's check another one. 1 0 0 0 1 0 0 0. We will get the answer 0 0 1 1, which is 0 0 1 1. Let's try here. Another input is 1 1 0 1 1 1 1 0 1, and we will get the answer 1 1 0 0 1 1 0 0. For the last input, all are 1 1 1 1 1, and we will get the output as 1 1 0 0 1 1 0 0. So our circuit is working properly. We are getting output for our inputs properly. As for the question, what is the clock frequency of the microcontroller used? We have used 16 megahertz. What is the data bus width of the microcontroller used? It is 8 bit. What is the size of your hex file generated, attach and file code, hex code in your report? Our hex file size is 4 kilobyte, and this is our hex file. So as for the hardware part, my teammate will describe it. Thank you, everyone.
Thank you. So here is our hardware implementation showcase, and as you can see, we have used Arduino Uno and then used a breadboard for connecting the LED, switch and resistors. These LED outputs are connected to the Arduino via the pins 10 to 13, and the results controlling them are 2 to 5 pins. Initially the state is 000 and the output is 0101. If we change the switch from 000 to 1100,
Wait.
a new state, the output will be 0001. Again, if the input is 0110, then the output shows 0110. For the next state, we will be changing this input to 0101. And the output according to the table would be also 0110. And lastly, our final state of the output will be 1111. And the output will be 0011. And now to explain the power consumption criteria of our project.
Question number 8. Exclusively comment on the input-output pair that will draw the maximum power assuming a single power supply is used for the system. So the answer of the question, we first need to see the pairs of the input and output, which will draw the maximum power. Here the inputs are 1101 and 0111, and the outputs are 1011 and other output is 1011. These input and output pairs will draw the maximum power which is required. Why? Because when the input is high, more power is needed, as well as when the output is high, more power is needed. Well, in order the calculate of power consumption table, we used their method for the external resistor current flow is 20 microamperes, and the power consumption of the battery is equal to VCC times 20 microamperes. The VCC is our input current is 3.3 volt, and the resistor R is 10 kilo ohms. As a result, we calculate all of the input power consumption using this method. For output, when the input level is high, VCC by R is the current flow through the external resistor, and the power consumption of the table is equal to VCC times current. When the input is set to 0, the external resistor's current flow is 0 ampere and the battery's power consumption is 0. The VCC is our output current is 3.3 volt and the resistor R is 220 ohms. As a result, we calculate all the output power consumption using this method. So now moving on the power consumption table. Here we can see the input output, input power and output power, and the total power consumption calculated adding input power with output power. And now we can see here the inputs 1101 and the output 1011. These are the maximum amount of power. Why? Because these are 7 active nodes and the most amount of energy to be supplied and the most amount of power to be needed. And table power consumption 0.1518 watts. As well as that we can see here for the inputs 0111 and for the output 1011. It also has 7 active nodes and also for their required highest amount of power supply and most amount of power needed. So for that this has also highest amount of power consumption. The maximum amount 0.1518 watts. Thank you for everyone.
As per the question number 4, which is can the project be implemented by using interrupt? The answer is yes. The project can be implemented by using interrupt. We know that interrupts are used by application systems to support hardware clocks, transport data to and from the storage such as hard drive devices as well as communication devices, handle support and mouse events, also to respond to another events which are time sensitive. Now as per question 5, which is the main routine required to be an infinite loop, provide an explanation in favor of your answer. The answer of this question is yes. The main routine is required to run in an infinite loop. The reason behind this is that the value doesn't update when it is not looped continuously. Hence, an infinite loop is required.